Hello, good morning. Greetings to everyone, and welcome to a continuation of our training session with K2 Innovative Tech. This is a continuation of our program KTech for All, a system analysis and design training solution. Today, we are going to be discussing about IT methodologies. I'm Kisinjaka, your companion, system analyst, software, and senior DevOps engineer. Today, we are going to be focusing on IT methodologies briefly. What's our expected plan? We're expected to understand what a methodology is all about, what an IT methodology is. We'll try to study three of them, or four: the DLC, the Agile, the Scrum, and then the DevOps briefly. Then in our subsequent training, we are going to zoom in on each of them. Now, because people grow from different areas based on our sociological background, physiological background, sometimes intellectual level of understanding, and to even an extent, our tribes can influence the manner in which we think, we do our thing, or what we consider as true or false, what we use as our views, our beliefs, our guides to make logical conclusion. Now, in order to bring up a uniformity at the level of science, analyzing a software is a scientific process. So that is the need of a methodology. And as you can see, it is a study of a research method, or more formally, contextual framework for research. A context, a framework through which you can carry out your research so that we can have a coherent, a logical scheme based on the views, what you consider as views to make your conclusions, the beliefs and the values and the guides, and what guides your choices or the choices of a researcher. So in the methodology, we are aimed at ensuring that we have a conceptual, contextual framework that guides all researchers so that we have a coherent and a logical manner in which we do our stuffs. Now, traditionally, some may have heard of the SDLC, software or system development lifecycle. But since we're in the domain of a software, our system here is a software. And traditionally, these are some of the stages that you may see: the planning, the defining, the designing, the building, the testing, and the development. The same stage is found on the right-hand side of this other diagram: software development lifecycle. The same thing: planning, requirement, which is defining, designing, coding, testing, deployment, and maintenance. Now, let's discuss these diagrams. Firstly, this is the same diagram, but expressed here now in 6 stages. Analysis. The analysis stage, as we saw in the former diagram, planning and requirement together. Here is contextualized under analysis. And basically, we have three things that are very important at the level of the analysis phase. One thing we should note is that when it comes to this most analysis done, you may follow the software development lifecycle because each project must have a lifecycle. Now, you may follow the system or software development lifecycle, but being implemented in other methods, maybe a waterfall approach, a spiral approach, a DevOps approach, an agile approach, or a Scrum approach, or an agile DevOps approach. Now, so we need to understand the concepts of the life cycle. Then we'll try to implement them in particular methodologies. Now, requirement analysis. It is important that before any software is put up, you have to analyze. The common English adage says, "What you plan to fail, When you fail to plan, you're planning to fail. So it is important for us to perform the analysis. And most of the time, this feasibility analysis focuses on three areas: the economic, the operational, and the technical areas. Economically, what do you need, maybe financially, for the setting up of the system? Which area best suits the implementation of this system for an improved or an increased economical achievement? Which market trend is important? What are the SWOT analysis of that particular product or of that particular software or of that particular environment? It is important that we do all of this. One thing we need to note is that the deliverables of one stage functions as the input of the next stage. Now, if you look carefully under the analysis, you're going to see one of the next point, which is remodeling of requirements. When the life cycle has gone completed and during the maintenance, maybe you observe some errors, we remodel the requirement. That is, to bring back the requirements and change it, or changing one or two things based on the observation we have seen. Now, there are concepts of modeling, concepts of prototyping, and concept of simulation. In an IT project, those three concepts, or in the IT domain, those three concepts are very important concepts. Model. Modeling is a process of creating a model, representing what we actually need to see in the real world, in the computer system, a model. Then from the model, we can create a physical prototype, or we simulate the model to understand how the automation is going to happen. So that is the most important thing under the analysis phase. And taking that the deliverable of one phase serve as input for the next phase. And now, one more reason why you should analyze is to understand the risk factor so that you can reduce the risk factor to the minimum possible stage. What are the risks associated with your project? You should understand all of this. Or you should try to state the quality assurance requirements. What will you need to be able to judge the quality of your software? It's important you analyze. It's important you put your requirement down. Now, most of the time, at the analysis phase, for example, the analysis phase sometimes helps you to prepare your quality assurance requirement, such that at the level of the design phase, from the diagram we see the design phase here composed of three: project planning, markups, and GUI designs. Now, when you have set up your quality assurance attribute, now at the level of the design phase, what are you doing? The design phase takes its input as a deliverable from the analysis phase. Now, you will need to set up a document that will consist of all the product requirements to be designed and developed during the project lifecycle. And this is what we refer to as SRS, Software Requirement Specification. In some other steps, it is specified at the level of the analysis phase. Here, you are supposed to specify all requirements, and you may ask yourself, what is a requirement? In our next video, we are going to be treating requirements, requirement analysis in full. Now, it can either be a user requirement, a business requirement, a functional requirement, a non-functional requirement, a system requirement. Now, project planning. As I said earlier, if you fail to plan, you're planning to fail. Each project should have a life cycle, the critical portion of the life cycle, what is the duration of each task executed within the life cycle. We need a project planning. You must plan your project as to the duration, the time at which a particular activity will need to be carried out, and what will be expected of that. Now, when the software requirement specifications are well designed and the communication language is well expressed, you can specify your SRS, your software requirement specifications, very well. But now we need to put an architectural diagram. Most engineers working together or stakeholders in the development of the project, may not necessarily need to read so much, but there are unified ways of modeling. You remember at the beginning we talked about modeling. Now, and in the era where we find ourselves, most tasks has to do with an instances representing real world objects in computer. That is why we are now with object oriented mode of doing things. In object oriented programming, now here we are prototyping, we are modeling, we are analyzing, we are designing. So we are focused with object oriented modeling. So now, for you to model and bring out the product architecture very well, you need to draw diagrams. And the drawing of the diagram can be documented using object modeling and design languages such as a unified modeling language. And when this communication is done, you can now bring out the various design, the various architectural designs, and document it in the document known as the design document specification. Thereafter, the graphic designers can now both understand the various modularity and how they can put them together and propose possible GUIs, graphical user interfaces designs of the final product. Now, this DDS is reviewed by all the important stakeholders and based on various parameters as risk assessment, product robustness, design modularity, budget, time constraint. The design approach is selected for the product. Remember the design approach that is selected for the product. When you have now been able to say, okay, what are the risks associated from the analysis stage? How shall our product be robust? What are the various modules, the design modularity? What is the budget, financial? What is the time constraint? And what is the best design approach? So that you don't start designing, you don't start developing, then before you start noticing some one or two things. So it is very important that all of this is done at this stage. Now, after our design has been done, development. The development, as we know, the name go, this is where you generate actually the coding. And it will depend now on your language of preference. But one thing I want us to note under this stage is the programming code is generated as per the documents we have just specified. Remember, the deliverable of a stage is input for the next stage. And if you remember carefully, in our former stage, our deliverable was the DDS, the design document specification. So that is what we use. Now, the code now is, at this stage, there's one thing you should know. In coding now, there's a manner in which you can do to test. You can decide now to implement your development in sprints. Well, we'll go further. We're going to see that that is the basic concept of agility. You can decide to implement it in sprints, or you decide to do it in a continuous manner. That is what we call continuous integration, continue monitoring, continue the develop continue monitoring, continue integration. You see, most of the tasks will become continuous, and that is the automation part which DevOps bring. So as we go further, but now in basic coding now, you can be testing your project a unit test or a system test. You can be doing that simultaneously. That's one thing you should not get. Unit test means you build a bit, you test, you build a bit, you test before you do the total testing. So based on the manner in which you be doing your development, it can then now, based on the way you do your development and deployment for the market, will now force you to choose one of the methods that we are going to see about, whether you are doing an agility something or you are doing a DevOps one another. Okay. Now, after the development stage, according to our diagram here, we have the testing stage. Testing stage. Testing, very important. Now, we are going to as well look at this from the various methodologies. Now, let's look at the testing. What are you trying to do here? You say, okay, initially you brought out your quality assurance requirements. Yeah, it is based on these quality assurance requirements that I can logically say that my software meets what it's supposed to do. And where was that specified? It was specified in the software requirement specification. So here you are trying to ensure that what is being developed meets the requirements that were stated in the SRS. Very important. Now, let's get to now the deployment or release to the market. You are releasing the market, And testing here again need to be done in a set in another level as well. Because you see, you have better release for UAT, user acceptance testing. When we get to DevOps, you are going to understand a bit how this dynamism. But here you are releasing to the market. You can do a second test. In sprints, like in agility, you do a second test. When it's good, you deploy out to the market. When it's not good, what do? You remodel. When it's good, you deploy. When it's not good, you remodel. So basically, these are some of the stages of the SDLC and how it can affect. Maintenance, of course, is one of the most important. Where you do the technical support, the bug fixings, the monitoring. Depending on what you do now, you see the monitoring aspect is coming into it. So maintenance, you must ensure a continuity in your maintenance services as well to your product. You shouldn't wait for the product for to have some bugs. You should continue doing the debugging process continuously, and we're going to see how some other methodologies does it dynamically. Okay, traditional SDLC methodologies we know waterfall, iterative, spiral, V-shape, big bang model, and in the waterfall model, as you can see, you leave from one stage to another. You leave from one stage to another, from the SRS, software design. We have just explained it in that particular loop. So basically, this is how you handle the waterfall model. It has its own drawbacks. The waterfall model has a drawbacks because the other members of the team remain idle. They do remain really idle, expecting when the first members finish, they need to give to the second member, before they give to the third member, before they give to the fourth member, to the fifth member. So when tax is not at any of the stages, the unit becomes really, really idle, and it leads to time consumption and wastage of resources because people are being paid while they are not working at all times. So these are major drawbacks of the waterfall model. Now, based on these drawbacks of the waterfall model, Briggs brought up the idea of agility, agile methodology. The agile methodology, as you can see on the diagrams, perform this by breaking the work into sprints, performing various sprints. Now, in the various sprints, now multiple tasks can be done by different groups and different. You do the modularity of the project there, and multiple persons can be done. You are doing the same thing that was done. You what do? You plan, you design, you develop, you test, you deploy, you review. And when you review is good, what happens to the review? When the review is good, you launch. That is, you are deploying it to the market. When it's not good, you remodel. But here it is more in spring. And one most advantage of agility or agile is that it has a high team velocity. It means it's automation. It makes work go really fast. But what happened? And people work more as a team. But what happened with agility? Once one member is not there, it affect the spring, and the effect of that spring affect the overall, and that is where DevOps come into play. DevOps, development operational. That's when DevOps comes into play. And if you look carefully, it's as if DevOps is the ampersand sign, as if it's a combination of the agility. So work is done here in a continuous manner, and in this continuity manner, you observe that the work is done, as we say, in a continuous manner. So there's no idle. There's no idleness. There is continual work. The release here is done continuously to the software is made really, really better. And most of the automation that is happening here are done with the help of softwares. So with the help of this software now, you see, you can use the software at the level of your build, at the level of where you store your code repository like a Git or a GitHub, so that the absence of a particular engineer does not really affect the overall chain, such that all can still get access to the same result. So basically, this was the introductory notions to IT methodologies, and I look forward to see you for subsequent video. Thank you very much and have a wonderful day.